but not a surprise. Dan Pope shows us the science behind this disaster.
Jed, you know, the seismograph stations monitored at the University of Utah are recording dozens and dozens of aftershocks to the massive quake in Japan, and they're interested in seeing if it has any effect in Utah or in the Yellowstone Park area. With an earthquake of this magnitude, seismograph waves shake the earth like a bell for months.
The rupture itself probably lasted for about 150 seconds, and the rupture probably moved over an area of hundreds of kilometers. So this was a massive, massive, massive earthquake.
Japan is on a subduction zone, which is where two plates are coming together. One plate is forced under the other one, and that makes the largest earthquakes in the world.
Well, Dr. Ron Harris, a BYU geologist, was just there in Sendai, Japan for an international conference a couple of weeks ago. He says massive earthquakes like this regularly shock this region, but we're unable to measure them less than a century ago.
And so when you have a large earthquake in one part of the world, it essentially transfers stress to other places that are just about ready to go, and all they need is just a little bit of a push.
Well, he says that today it is very consistent with what has happened in the past. That area ruptured in the 1890s. Now, early estimates on the tsunami, not quite as big as the one in 2004 in the Indian Ocean. This was an 8.9, that was a 9.1. It's also possible an aftershock could be triggered by, or could trigger another tsunami, especially early on. Jed?
All right, thanks a lot, Dan. And we're going to be